Welcome to the Certified Marine Wildlife Conservation Professional course, a comprehensive journey into the world of marine conservation. This program is designed for those passionate about protecting our oceans and the incredible diversity of life they support. Over the next 15 chapters, you'll gain insights from experts and learn about the latest strategies in conservation. The ocean is Earth's life support system, covering 71% of its surface and producing 50% of the oxygen we breathe. It absorbs 25% of carbon dioxide emissions and 90% of excess heat, playing a crucial role in regulating the global climate and supporting life. Marine environments boast extraordinary biodiversity, with an estimated 250,000 to 300,000 known marine species. From coral reefs to hydrothermal vents, these ecosystems are vital for maintaining the planet's ecological balance. The state of the ocean is alarming, with a 49% decline in species and 34% of fish stocks overfished. Coral reefs have lost 50% of their cover, and 8 million tons of plastic enter the ocean annually, highlighting a crisis that demands urgent action. Marine wildlife conservation is crucial not just for the environment but also for global economic stability. It supports food security, coastal protection, and pharmaceutical development, with an estimated annual economic value of $24 trillion. The history of marine conservation spans over a century, evolving from awareness to action. Key milestones include international treaties and frameworks that have shaped modern conservation efforts. Marine wildlife faces numerous threats, including overfishing, climate change, pollution, habitat destruction, and invasive species. These challenges are interconnected and require comprehensive strategies to address. Marine conservation biology provides the scientific foundation for conservation strategies. It includes population viability analysis, connectivity science, and molecular genetics to understand and protect marine species. Effective marine conservation requires governance at global, regional, national, and community levels. Policies and agreements must be implemented and enforced to protect marine ecosystems. Technology is revolutionizing marine conservation, with tools like satellite remote sensing, acoustic monitoring, and environmental DNA enhancing our ability to monitor and protect marine life. The economic value of ocean ecosystems is immense, with direct, indirect, and non-use values contributing to global economic stability. Blue carbon markets and marine protected areas are vital for sustainable development. Indigenous and local communities play a crucial role in marine conservation. Their traditional knowledge and legal rights are essential for effective and sustainable conservation efforts. Climate change is the defining challenge for marine conservation, affecting every aspect of marine ecosystems. Strategies must be adaptive and resilient to address the impacts of ocean warming, acidification, and sea level rise. This course covers every major dimension of marine wildlife conservation, from ecosystem science to professional certification. You'll learn about threats, legal frameworks, and conservation strategies to enhance your career. The Great Barrier Reef Marine Park Authority exemplifies successful marine conservation, with zoning systems and management strategies that protect this vital ecosystem despite challenges like coral bleaching. The ocean is vital to our planet, and CDG training equips you with the knowledge and skills needed for effective conservation. With scientific excellence, policy mastery, and professional impact, you'll be ready to make a difference. To protect marine wildlife effectively, we must first understand the extraordinary diversity and complexity of the ecosystems in which wildlife lives. This includes the physical environments, ecological structures, biological communities, and functional processes that together constitute the living ocean. From sun-drenched tropical coral reefs to the crushing depths of the abyssal plain, the ocean encompasses a breathtaking range of ecological environments that rival the diversity of terrestrial biomes in their complexity and biological richness. The ocean is structured into distinct zones, each with unique characteristics. From the intertidal zone with its tidal exposure to the abyssal zone's crushing pressure, these layers support diverse marine life. Understanding these zones helps us appreciate the ocean's complexity and the life it sustains. Coral reefs are the most biodiverse marine ecosystems, supporting 25% of all known marine species. These vibrant underwater rainforests are crucial for marine life, providing habitat and food. Major biogeographic centers like the Caribbean and the Coral Triangle are hotspots of reef biodiversity. Mangroves are coastal sentinels, offering protection against erosion, carbon sequestration, and vital habitats for fish species. Despite their importance, mangroves have been significantly reduced due to human activities, highlighting the need for conservation efforts. Seagrass meadows, though often overlooked, are vital for coastal ecosystems. They store carbon, stabilize sediment, and provide habitat for marine life. However, they are declining rapidly, emphasizing the need for protection and restoration. Kelp forests, known as temperate ocean cathedrals, are dynamic ecosystems with towering algae that support diverse marine life. They are crucial for maintaining ecological balance but face threats from climate change and human activities. Pelagic ecosystems, the open ocean, are structured around nutrient movement and food web hierarchies. These ecosystems support a wide range of marine life, from tiny phytoplankton to large apex predators, highlighting the ocean's interconnectedness. The deep sea, covering 95% of the ocean's habitable volume, is a frontier of marine biodiversity. It hosts unique ecosystems like cold water corals and hydrothermal vents, which are crucial for understanding ocean life and require protection from human threats. Marine food webs illustrate the energy flow and trophic dynamics within ecosystems. Understanding trophic cascades is crucial for conservation, as changes in predator populations can impact entire ecosystems, highlighting the importance of maintaining balance. Marine biodiversity hotspots like the Coral Triangle and Galapagos Marine Reserve are vital for conservation. These areas support a significant portion of the world's marine species, emphasizing the need for global efforts to protect these rich ecosystems. Ocean productivity is driven by nutrient cycling and upwelling systems like the Benguela and Humboldt currents. These systems support rich marine life and are influenced by climatic events, highlighting the ocean's dynamic nature and the need for sustainable management. Connectivity in marine ecosystems is crucial for species survival and adaptation. Currents, larva dispersal, and migration link distant populations, emphasizing the need for integrated conservation strategies to maintain these vital connections. Marine environments provide essential ecosystem services, from provisioning food to regulating climate. These services support billions of people and highlight the human dimension of ocean conservation, emphasizing the need for sustainable management. The Coral Triangle Initiative exemplifies regional cooperation in marine conservation. By connecting nations and communities, it addresses shared challenges and promotes sustainable management of marine resources, showcasing the power of collaboration. Understanding the structure, function, and biodiversity of marine ecosystems is crucial for effective conservation. Science-based policy and professional commitment are essential to protect these vital environments for future generations. From overfishing to climate change, this chapter delves into the major threats facing marine wildlife. It highlights the interconnected pressures reshaping marine ecosystems worldwide. Understanding the threats to marine wildlife is crucial for effective conservation. This section explores the convergence of threats and why interactions matter, emphasizing the need for a comprehensive threat assessment. Overfishing is the most widespread threat to marine species, affecting their ability to reproduce and maintain viable populations. This section examines the alarming statistics and the cascading ecological consequences. Bycatch, the unintentional capture of non-target species, poses a severe threat to marine life. This section highlights the impact on sea turtles, marine mammals, seabirds, and sharks, emphasizing the need for effective bycatch reduction strategies. Illegal, unreported, and unregulated fishing is a significant governance failure, undermining conservation efforts. This section discusses the scale of the problem and the need for international cooperation and enforcement. The destruction of marine habitats eliminates essential environments for species. This section covers coral reef destruction, bottom trawling, coastal development, and dredging, highlighting their impact on marine biodiversity. Marine plastic pollution is a global environmental crisis affecting countless species. This section discusses the scale of plastic waste and its impact on marine life, emphasizing the need for system-level solutions. Chemical pollutants and nutrient pollution create dead zones and affect marine biodiversity. This section explores the impact of persistent organic pollutants, heavy metals, and nutrient pollution on ocean health. Underwater noise pollution disrupts marine life communication and navigation. This section examines the sources and consequences of acoustic pollution, highlighting the need for acoustic management standards. Invasive species threaten marine environments by altering habitats and displacing native species. This section explores their introduction, spread, and ecological impact, emphasizing the need for control measures. Climate change is altering the ocean's physical and chemical properties, affecting marine wildlife. This section discusses sea surface warming, coral reefs at risk, and the broader impacts on marine ecosystems. Ocean acidification, caused by CO2 absorption, threatens marine organisms by altering their environments. This section highlights the impact on vulnerable species and the broader ecological consequences. Illegal wildlife trade in marine species extends beyond fisheries, threatening biodiversity. This section discusses the trade in sharks, seahorses, sea cucumbers, and more, emphasizing the need for international regulations. The cumulative impact of multiple threats can devastate marine ecosystems. This section uses examples like coral reefs and sea turtles to illustrate how combined pressures affect marine life. The Gulf of Mexico dead zone exemplifies the impact of nutrient pollution and habitat degradation. This section explores the causes and consequences, highlighting the need for effective conservation strategies. The threats to marine wildlife require integrated conservation strategies that combine scientific depth, policy sophistication, and strategic creativity. This section emphasizes the need for comprehensive responses to build resilience for an uncertain future. In this CDG training chapter, you'll gain a comprehensive understanding of major international legal frameworks governing marine wildlife conservation. From the architectural structure of UNCLOS through CITES and the Convention on Migratory Species, to the landmark High Seas Treaty and the emerging Kunming-Montreal Framework, you'll master the legal landscape that underpins effective ocean governance. Adopted in 1982, UNCLOS is the foundational legal framework governing all human activities in the ocean. It establishes the legal geography of the seas, defining rights and responsibilities of nations concerning ocean use. Articles 192 and 194 emphasize the protection and preservation of the marine environment, setting the stage for sustainable ocean governance. Exclusive Economic Zones, EEZs, extend 200 nautical miles from coastlines, granting coastal states rights over marine resources. However, effective EEZ conservation is crucial, as it depends on creating enforceable boundaries and sustainable management practices, especially for nations with limited resources. The high seas, covering 64% of the ocean's surface, have long been beyond national jurisdiction. The 2023 BBNJ agreement marks a significant advancement, introducing tools for conservation and sustainable use of marine biodiversity in these vast areas, ensuring protection for some of the most vulnerable ecosystems. The Convention on Biological Diversity, ratified by 196 parties, aims to protect biodiversity across all ecosystems. The Kunming-Montreal Global Biodiversity Framework, adopted in 2022, sets ambitious targets for conservation, aiming to protect 30% of land and ocean areas by 2030, marking a pivotal moment in global biodiversity efforts. CITES, adopted in 1973, is a critical international agreement regulating trade in endangered species. With 184 parties, it ensures that international trade does not threaten species survival, listing species under 3 appendices based on their conservation status and trade impact. The Convention on Migratory Species, established in 1979, is the only global environmental treaty focused on migratory animals. It addresses threats to these species across their migratory routes, with specific appendices listing species that require international cooperation for their conservation. The International Whaling Commission, formed in 1946, regulates whaling and promotes conservation. Despite challenges, it has played a crucial role in the recovery of whale populations, particularly in the North Atlantic and Southern Hemisphere, highlighting the importance of international cooperation. Regional fisheries management organizations are key in managing fish stocks and other marine resources. They address challenges like overfishing and ecosystem impacts, ensuring sustainable practices across multiple nations' jurisdictions, and adapting to scientific advice for effective conservation. The Antarctic Treaty System, including the CCAMLR, governs human activities in the Antarctic, focusing on conservation and sustainable use of marine resources. It represents one of the most comprehensive frameworks for protecting the unique ecosystems of the Southern Ocean. The OSPAR Convention, established in 1992, protects the marine environment of the Northeast Atlantic. It focuses on ecosystem protection, pollution prevention, and the conservation of threatened species, using an ecosystem approach to manage human activities and ensure sustainable use of marine resources. While international frameworks set the stage, national legislation is crucial for effective marine conservation. Strong laws, like the U.S. Marine Mammal Protection Act, highlight the importance of enforcement and the need to address gaps in policy to ensure comprehensive protection of marine environments. Environmental impact assessments are vital for understanding the potential effects of projects on marine environments. They involve evaluating physical, chemical, and biological impacts, and are essential for informed decision-making and sustainable development in marine areas. Non-governmental organizations play a crucial role in marine conservation, from treaty negotiation to scientific assessment and strategic litigation. Their involvement ensures that conservation efforts are informed by science and that international obligations are met, protecting marine biodiversity effectively. The Commission for the Conservation of Antarctic Marine Living Resources exemplifies international cooperation in marine conservation. It highlights the importance of ecosystem-based management and the challenges faced in balancing conservation with sustainable use, particularly in the Southern Ocean. International legal frameworks are not just bureaucratic instruments. They are the governance architecture that determines whether marine wildlife receives the protection it needs. Mastering this legal landscape is crucial for conservation professionals, as it underpins every strategy and recovery plan. Marine protected areas are crucial tools in marine conservation, focusing on design, management, and effectiveness. They encompass ecological design principles and global governance frameworks to ensure sustainable marine environments. The history of marine protected areas spans traditional practices to modern governance. From the first large-scale marine park in 1935 to the 30 by 30 target in 2022, MPAs have evolved significantly. Effective MPA design relies on ecological principles like comprehensiveness, adequacy, representativeness, and effectiveness. These principles ensure biodiversity protection and ecosystem integrity. Zoning within MPAs balances conservation with human use. Different zones, like sanctuary and habitat protection, ensure sustainable use while preserving critical areas. The spillover effect of MPAs enhances fish biomass and benefits fisheries. Studies show fish biomass inside reserves is significantly higher, supporting sustainable fishing practices. MPA governance ranges from state-controlled to community-based management. Co-management approaches enhance effectiveness by involving local communities and stakeholders. Effective enforcement is crucial for MPA success. Mechanisms like patrols and electronic monitoring address the paper parks problem, ensuring compliance and protection. Financing MPAs is challenging, with a significant funding gap. Innovative solutions like visitor revenue and blue carbon credits are essential to bridge this gap. Marine spatial planning allocates ocean space for ecological and social objectives. It involves mapping spatial data and ecological values to manage the marine seascape effectively. Assessing MPA effectiveness involves measuring conservation success and distinguishing protection effects from natural variation. This ensures MPAs meet their objectives. Climate-smart MPA design adapts to climate change impacts. Strategies like thermal refugia and dynamic ocean management ensure resilience under changing conditions. No-take zones significantly outperform multiple-use MPAs in fish biomass. Scientific evidence supports their effectiveness in marine conservation. Deep sea and high seas MPAs represent a new frontier in marine conservation. They address unique challenges and opportunities in these vast, unexplored areas. The Chagos Marine Protected Area exemplifies large-scale no-take zones. It highlights the challenges and successes of implementing extensive marine conservation efforts. Marine protected areas are vital for ocean conservation. Their success depends on ecological design, governance quality, adequate financing, and professional excellence. Coral reefs are the most biodiverse and ecologically productive marine ecosystems on Earth, yet they face significant threats. This chapter delves into the science, threats, and restoration efforts crucial for their conservation. Understanding coral biology is essential for effective conservation. Coral reefs are built by marine invertebrates called corals, which form symbiotic relationships with algae. This partnership is vital for the reef's health and resilience. Coral bleaching is a visible sign of climate stress, caused by heat spikes and other environmental changes. It leads to corals turning white and can result in their death if conditions don't improve. Ocean acidification, caused by increased carbon dioxide absorption, affects coral calcification. This process threatens the structural integrity of reefs, making them more vulnerable to erosion and other stresses. Local threats like overfishing, pollution, and coastal development exacerbate coral reef degradation. Addressing these issues is crucial for the resilience and recovery of coral ecosystems. The crown-of-thorns starfish is a natural predator of corals, causing significant damage during outbreaks. Effective management and control are essential to protect coral cover from these starfish. Long-term monitoring of coral reefs provides essential data for conservation management. Techniques like transects and surveys help evaluate the health and recovery of these ecosystems. Coral reef restoration involves techniques like coral gardening and microfragmentation to accelerate recovery. These methods are crucial for restoring degraded reefs and enhancing their resilience. Assisted evolution techniques, including selective breeding and genetic modification, aim to create climate-resilient corals. These methods help corals adapt to changing ocean conditions. Manipulating the symbiotic relationships within corals can enhance their thermal tolerance. This approach, along with microbiome enhancement, offers promising avenues for coral conservation. The 2023-2024 Global Bleaching Event underscores the urgent need for coral reef management. It highlights the importance of international cooperation and innovative conservation strategies. Effective coral reef conservation requires coordinated efforts across international, regional, and local levels. Policy frameworks and economic incentives play a crucial role in these efforts. The Great Barrier Reef Restoration and Adaptation Program is a comprehensive initiative aimed at enhancing reef resilience. It employs innovative techniques to protect and restore this iconic ecosystem. Coral reef conservation is vital for marine biodiversity and human communities. The reefs we protect today will determine the future of marine ecosystems and the livelihoods of millions of people. Marine mammals are a unique and profound part of our planet, living at the intersection of the ocean and human imagination. They are among the most evolutionarily remarkable and emotionally resonant groups of animals. This presentation explores their biology, conservation status, and the urgent need for their protection. Marine mammals encompass approximately 130 living species across 5 distinct taxonomic orders. Each represents an independent evolutionary return to the marine environment from terrestrial ancestors, showcasing the diversity of marine life. Cetaceans have adapted to ocean life through unique physiological traits like blubber for thermoregulation and specialized diving capabilities. These adaptations make them some of the most efficient marine predators. The conservation history of great whales is a dramatic narrative of ecological catastrophe and recovery. From the 10th century to the present, efforts have been made to protect these majestic creatures from extinction. Dolphins and porpoises face significant threats, with some species like the Maui dolphin and the vaquita nearing extinction. Conservation efforts are critical to prevent their disappearance. Pinnipeds, including seals, sea lions, and walruses, play a crucial role in marine ecosystems. However, they face threats from habitat loss and human activities, making conservation efforts vital. Sirenians, such as dugongs and manatees, are gentle marine mammals facing threats from human activities like boat strikes. Conservation programs are essential to protect these unique species. Entanglement in fishing gear and vessel strikes are major threats to marine mammals, causing hundreds of deaths annually. Addressing these issues is crucial for their survival. Acoustic pollution from military sonar, seismic airguns, and commercial shipping disrupts marine mammals' communication and navigation, posing significant threats to their survival. Climate change is altering the habitats and behaviors of marine mammals, with significant impacts on species like polar bears, narwhals, and walruses. Understanding these changes is vital for conservation. Protected areas and critical habitat designations are essential for marine mammal conservation, providing legal mechanisms to safeguard their environments from harmful activities. Research methods like photo identification, acoustic monitoring, and satellite telemetry are crucial for studying marine mammals, helping scientists understand and protect these elusive creatures. Whale watching is both a conservation tool and a threat, generating significant revenue while potentially disturbing marine life. Balancing these aspects is key to sustainable practices. The North Atlantic Right Whale Recovery Program is a critical case study in marine conservation, highlighting the challenges and successes in protecting this endangered species. Marine mammals are more than symbols of ocean conservation. They are ecological engineers, cultural ambassadors, and biological indicators. Protecting them is crucial for the health of marine ecosystems. Among the most ancient and ecologically significant, sea turtles, sharks, and rays are crucial to marine ecosystems. Their loss would trigger cascading effects across the ocean food web. Sea turtles are biologically remarkable, with unique life history characteristics. They exhibit natal philopatry, have extended longevity, and depend on temperature for sex determination. All 7 sea turtle species are listed as threatened, with varying degrees of vulnerability. Conservation efforts are crucial to reverse their declining populations. Protecting nesting beaches is vital for sea turtle conservation. Core activities include monitoring, reducing disturbances, and managing artificial light to protect hatchlings. Sharks have evolved over 450 million years, showcasing extraordinary senses and a wide trophic range. Understanding their ecological roles is crucial for conservation. Sharks face unprecedented threats, with millions killed annually. The ecological impact of their decline disrupts marine ecosystems, highlighting the need for urgent conservation. Conservation requires international cooperation and innovative strategies like shark sanctuaries. These efforts aim to protect shark habitats and regulate trade effectively. Rays are among the most threatened marine vertebrates. Conservation efforts focus on reducing threats from trade and promoting sustainable tourism. Advanced research methods like satellite tags and environmental DNA are crucial for studying sharks and rays, providing insights into their behavior and aiding conservation. Bycatch mitigation is essential for protecting sea turtles, sharks, and rays. Innovative devices and fishing practices help reduce mortality without affecting fisheries. Illegal trade in sea turtle and shark products is a significant threat. CITES regulations and enforcement are vital for sustainable conservation efforts. Community-based conservation empowers local communities to protect marine species. Engaging stakeholders leads to more effective and sustainable conservation outcomes. Climate change affects sea turtles, sharks, and rays by altering habitats and food availability. Resilient strategies are needed to mitigate these impacts. The Totiguero program in Costa Rica integrates conservation and community development, showcasing effective strategies for protecting sea turtles and supporting local economies. Sea turtles, sharks, and rays are ancient ocean architects. Their conservation is crucial for maintaining ecological balance and requires innovative and committed efforts. Seabirds are among the most ecologically remarkable and conservation-challenged groups, serving as sentinels of ocean health. With a significant population decline since 1950, they face threats from habitat loss and climate change. Seabirds have evolved unique adaptations like pursuit diving and dynamic soaring to thrive in ocean environments. These adaptations are crucial for conservation efforts and understanding their biology. Albatrosses and petrels, with their long lifespans and unique breeding habits, are masters of the Southern Ocean. However, they face threats from invasive species and require urgent conservation measures. Penguins, especially the African, Galapagos, and Emperor species, are iconic yet critically endangered. They face threats from climate change and human activities, necessitating urgent conservation actions. Seabird breeding colonies require multi-level threat management to protect against invasive species and human disturbances. Effective management ensures the survival of these vital populations. Invasive species on seabird islands pose significant threats to native wildlife. Successful eradication efforts, like those on South Georgia, highlight the importance of addressing these threats. Longline fisheries are a leading cause of seabird mortality. Implementing bycatch mitigation measures is crucial to reduce the devastating impact on seabird populations. Coastal waterbirds like herons and egrets play vital roles in their ecosystems. Conservation efforts have helped recover populations affected by historical exploitation. Shorebirds are highly migratory, facing significant declines due to habitat loss and climate change. Conservation efforts are critical to protect these species along their migratory routes. Oceanic islands are biodiversity hotspots but face vulnerabilities from invasive species and habitat loss. Restoration efforts are essential to preserve these unique ecosystems. Artificial light pollution disrupts seabird navigation and increases mortality. Mitigation measures, such as light shielding and public education, are vital to protect these species. Climate change affects seabirds through habitat compression and increased storms. Adaptive management responses are necessary to mitigate these impacts and protect seabird populations. Research methods like colony counts and GPS tracking are essential for understanding seabird populations and informing conservation strategies. The Albatross Task Force demonstrates effective bycatch reduction strategies, significantly decreasing seabird mortality in fisheries through innovative techniques. Seabirds are indicators of ocean health, requiring conservation efforts that integrate ecological knowledge, technical ingenuity, and international collaboration to ensure their survival. Fisheries represent the oldest, most geographically widespread, and most economically consequential form of human exploitation of marine wildlife. Providing the primary source of animal protein for over 3 billion people globally, supporting 600 million livelihoods, and generating annual revenues exceeding $400 billion USD. Yet, the very bounty of the ocean is causing ecological damage that threatens both the long-term sustainability of fisheries and the broader biodiversity of the ocean. Fisheries biology, the science of fish population dynamics and quantitative stock assessment, provides the foundational knowledge base for evidence-based fisheries management. Fish populations are governed by 4 fundamental demographic processes: recruitment, growth, natural mortality, and fishing mortality. Understanding these processes is crucial for maintaining the maximum sustainable yield, although critiques highlight the need for a more ecosystem-based approach. Stock assessment, the scientific evaluation of fish population size, biomass, age structure, reproductive rate, and exploitation rate, is the primary tool through which fisheries managers determine how many fish exist, how many are being caught, and how many can be sustainably harvested. Techniques like catch per unit effort, virtual population analysis, and acoustic surveys are essential for maintaining high catch rates even as populations collapse. The institutional architecture of fisheries management encompasses multiple levels of governance, from community-level customary management through national agencies to regional and global frameworks, each with different authorities, capacities, and effectiveness. Capacity gaps remain a significant challenge, highlighting the need for strengthening management frameworks and conservation practices. Ecosystem-based fisheries management considers the ecological context, interactions, and consequences of fishing in addition to the population dynamics of individual target species. This approach seeks to maintain the structure, diversity, and resilience of marine ecosystems while achieving sustainable yields. It represents one of the most important conceptual advances in fisheries science over the last 2 decades. Small-scale fisheries, using small vessels and simple gear types, employ the vast majority of the world's fishers and provide the primary source of food security and livelihoods for hundreds of millions of coastal families in developing countries. The conservation livelihood link is crucial, as community-based co-management can achieve both conservation outcomes and livelihood resilience. Bycatch, the unintentional capture of non-target species in commercial fishing gear, is one of the most pervasive and ecologically damaging dimensions of global fisheries. It affects a wide range of species, including those threatened or endangered, and poses significant challenges to conservation efforts. The ecological impacts of commercial fishing vary dramatically between different gear types. Understanding the specific impacts, selectivity characteristics, and bycatch potential of each gear type is fundamental professional knowledge for conservation practitioners. The development and adoption of bycatch mitigation measures, such as turtle excluder devices, circle hooks, illuminated fishing nets, and acoustic pingers, are crucial for reducing incidental capture without compromising target catch efficiency. These technologies represent engineering solutions for conservation. The Marine Stewardship Council, established in 1997, operates the world's most widely recognized and commercially significant seafood certification and eco-labeling program. It aims to maintain target fish populations at healthy levels, minimize environmental impacts, and ensure effective management systems are in place. The detection and enforcement of illegal, unreported, and unregulated fishing is a critical and rapidly evolving area of fisheries conservation practice. With technological advances creating new capabilities for identifying and responding to IUU fishing, enforcement is more effective than ever before. The relationship between fisheries conservation and global food security is one of the most important and most frequently misunderstood dimensions of conservation. Protecting marine wildlife and feeding humanity are not competing objectives, they are two dimensions of the same imperative. Rights-based fisheries management, the allocation of defined, legally enforceable entitlements to fish resources to individuals, vessels, companies, or communities, is one of the most influential and most debated approaches to achieving sustainable fisheries governance. It offers a way to enhance the cooperative catch fishery behavior that underlies open access conditions. The Patagonian toothfish fishery, targeting the deep-dwelling apex predator species Dicysticus eleginoides across its Antarctic waters, provides one of the most instructive case studies in the use of coordinated, ecologically informed management to achieve certified sustainability. Sustainable fisheries management is not a concession to environmental idealism. It is the scientifically demonstrated path to feeding more people more nutritiously from a healthier ocean, and the conservation professionals who master the science, governance, and stakeholder dynamics are building the foundations of the food-secure, ocean-healthy future that both humanity and marine wildlife urgently need. The ocean has long been a dumping ground for human waste, but the scale and persistence of pollutants are now threatening marine ecosystems. From plastic debris to chemical contaminants and noise pollution, each factor plays a role in this complex issue. Marine plastic pollution is one of the most visible environmental issues today, with millions of tons entering the ocean annually. Mismanaged waste, fishing gear, and industrial plastics are key contributors to this crisis. Macroplastic debris poses direct threats to marine wildlife through entanglement and ingestion. Ghost gear entangles marine animals, while ingestion impacts seabirds and whales, causing severe health issues. Microplastics, smaller than 5 mm, are pervasive in marine environments. They pose physical threats and carry chemical contaminants, affecting marine life at every level of the food chain. Persistent organic pollutants, or POPs, accumulate in marine organisms, leading to bioaccumulation and toxicity in apex predators. These compounds are resistant to environmental degradation, posing long-term risks. Heavy metals like mercury and lead contaminate marine environments, affecting wildlife through pathways such as predatory fish consumption and reproductive impairment in birds. Nutrient pollution from agricultural runoff leads to algal blooms and hypoxia, severely damaging marine ecosystems. This process, known as eutrophication, disrupts the balance of marine life. Oil spills, like Exxon Valdez and Deepwater Horizon, have devastating long-term impacts on marine life and habitats. These events highlight the need for specialized response and restoration efforts. Underwater noise from shipping and industrial activities disrupts marine life communication and navigation. Effective management requires comprehensive noise pollution strategies. Light pollution affects marine life, particularly sea turtles and coral reefs. Implementing turtle-safe lighting and regulating offshore vessel lighting can mitigate these impacts. Pharmaceuticals and chemicals like endocrine disruptors and sunscreen compounds are emerging threats to marine ecosystems. Policy solutions are essential to address these contaminants. The Global Plastics Treaty represents a significant step towards international cooperation in reducing plastic pollution. Conservation organizations are advocating for systemic changes to address this global issue. Effective response to marine pollution involves both immediate wildlife rescue and strategic debris removal. These efforts complement systemic solutions to reduce pollution sources. The International Coastal Cleanup mobilizes millions of volunteers worldwide to remove debris from oceans. This initiative highlights the power of direct action, data collection, and policy advocacy. Marine pollution is not inevitable. Through scientific evidence, regulatory innovation, technological solutions, and professional advocacy, we can reduce its impact and protect ocean ecosystems. Climate change poses a significant challenge to marine wildlife conservation, affecting every marine ecosystem and species. This chapter focuses on the impacts and adaptation strategies necessary for marine conservation practitioners. Understanding the physical mechanisms of ocean climate change is crucial. The greenhouse effect, ocean heat absorption, increasing stratification, and thermohaline circulation are key processes altering ocean conditions. Ocean warming has led to significant ecological consequences, including shifts in marine species ranges, increased frequency of marine heatwaves, and changes in community structures across ecosystems. Ocean acidification, driven by increased CO2 absorption, poses a threat to marine life, affecting calcifying organisms and impairing fish sensory systems, with projections indicating worsening conditions. Sea level rise threatens coastal marine habitats, impacting turtle beaches, mangrove forests, and coral reefs, with significant changes observed over the past century. Changes in ocean circulation, such as the weakening of the AMOC and shifts in coastal upwelling systems, have far-reaching ecological consequences, affecting marine ecosystems and climate patterns. Polar ocean ecosystems are experiencing climate change at an accelerated rate, with significant impacts on Arctic sea ice and Antarctic krill, highlighting the urgent need for conservation efforts. Tropical marine ecosystems, including coral reefs and seagrass meadows, are highly vulnerable to climate change, with significant degradation and functional destruction observed. Climate adaptation strategies for marine conservation include climate refugia conservation, assisted migration, ecological redundancy, and climate-smart planning to address ongoing and projected climate impacts. Ocean-based climate solutions, such as blue carbon ecosystems, voluntary carbon markets, and offshore wind energy, play a crucial role in mitigating climate change impacts on marine environments. Integrating climate change with other marine threats requires resilience-based management, focusing on reducing local stressors, protecting habitats, and restoring ecosystems. Effective communication and advocacy are essential for marine conservation, emphasizing emotional engagement, solution-focused framing, and personal relevance to inspire action. The IPCC provides a comprehensive foundation for understanding ocean science and conservation, with key projections and findings highlighting the urgency of addressing climate change impacts. The ocean crisis is immediate, requiring understanding, adaptation, communication, and advocacy to address the most consequential environmental issue of our time. Understanding and conserving marine wildlife requires a systematic approach to scientific monitoring and research. This chapter explores the methodologies essential for observing and protecting marine life, emphasizing the importance of evidence-based conservation. Underwater visual census is a key method for monitoring reef fish populations. Techniques like belt transect and point count methods help in identifying species and assessing their abundance, while considering factors like diver avoidance and observer variability. Baited remote underwater video, BRUVs, is a powerful tool for observing elusive marine species. By attracting and recording marine life, BRUVs provide valuable data for conservation efforts, supported by initiatives like Global Archive. Acoustic monitoring captures the sounds of marine life, from whale songs to echolocation clicks. This method, enhanced by machine learning, helps in understanding species distribution and behavior over vast ocean areas. Satellite and aerial surveys offer a bird's-eye view of marine wildlife. Techniques like drone photogrammetry and satellite imagery provide accurate data on species distribution and abundance, crucial for conservation planning. Animal telemetry involves tracking devices that record and transmit data on marine animals' movements and behaviors. This technology provides insights into migration patterns and habitat preferences, aiding in conservation management. Mark recapture methods estimate population sizes by identifying individual animals through unique markings. This technique is vital for understanding species abundance and informing conservation strategies. Environmental DNA, EDNA, revolutionizes marine monitoring by detecting genetic material in water samples. This method allows for the identification of species presence and abundance, offering a non-invasive approach to conservation. Remote sensing collects ocean data from satellites and autonomous vehicles, providing a comprehensive view of marine environments. This technology supports conservation efforts by monitoring ocean conditions and wildlife habitats. Citizen science empowers volunteers to contribute to marine wildlife monitoring. Platforms like iNaturalist and Whale Alert engage the public in data collection, enhancing research and conservation efforts. Long-term marine monitoring programs are crucial for understanding ecological changes over time. These programs ensure consistent data collection, aiding in the stewardship of marine resources across generations. Integrating multiple monitoring methods enhances marine conservation efforts. By combining techniques like aerial surveys and genetic sampling, a comprehensive understanding of marine ecosystems is achieved. Global Fishing Watch exemplifies the use of advanced technology in marine monitoring. By analyzing satellite data and employing machine learning, it provides real-time insights into global fishing activities, promoting sustainable practices. Marine wildlife monitoring is essential for conservation, providing the data needed to make informed decisions. Key takeaways include the importance of accuracy, representativeness, temporal consistency, and evidence-based action. Marine wildlife conservation is more than just science and regulation. It's about people, prosperity, and the future of our oceans. The ocean supports livelihoods, food security, and economic prosperity for millions, making it crucial to understand how decisions impact conservation efforts. Community engagement is essential for effective marine conservation. It involves free, prior, and informed consent, equitable benefit sharing, meaningful participation, and long-term relationship building. These elements ensure better conservation outcomes and stronger community governance. Traditional ecological knowledge, the ocean's oldest science, plays a vital role in conservation. It integrates with modern practices to enhance biodiversity protection. Recognizing this knowledge through conventions and rights instruments is crucial for sustainable conservation efforts. Locally managed marine areas, LMMAs, are a successful model of community-based marine conservation. They demonstrate how community engagement and ecological practices lead to effective management and conservation of marine resources. Addressing conservation colonialism involves adopting human rights-based frameworks. These include rights to free, prior, and informed consent, equitable benefit sharing, and remedy. Such approaches ensure conservation respects and benefits communities. The blue economy integrates marine conservation with economic development, focusing on sustainable practices in fisheries, shipping, tourism, and biotechnology. Understanding its potential and risks is essential for aligning conservation with development interests. Marine conservation finance faces a significant resource gap. Solutions like debt for nature swaps, blue bonds, PES, and impact investment are crucial for generating financial resources to support conservation efforts and bridge this gap. Marine tourism, including dive tourism and whale watching, generates substantial economic value. It supports conservation by providing economic incentives for protecting marine environments, highlighting the importance of managing visitor impact sustainably. Payment for ecosystem services, PES, provides financial incentives for conservation. By compensating communities and managers, PES supports sustainable marine resource management, ensuring conservation efforts are fair, effective, and financially sustainable. Reforming harmful fisheries subsidies is crucial for sustainable fisheries management. The WTO agreement on fisheries subsidies marks a significant step, but ongoing negotiations are needed to address broader conservation challenges and economic distortions. Philanthropy and NGO funding are vital for marine conservation, supporting research, advocacy, and community initiatives. Understanding how funding decisions are made is essential for developing effective conservation strategies and prioritizing interventions. Impact investment offers significant opportunities for marine conservation finance. By focusing on sustainable fisheries, coastal real estate, and vertical impact measurement, it provides a growing market for funding conservation efforts and sustainable development. The Seychelles Debt for Nature Swap is a successful example of innovative conservation finance. It demonstrates how restructuring debt can fund marine protected areas and support sustainable management, offering a model for replication in other regions. Effective marine conservation requires integrating community engagement, blue economy principles, and innovative finance. By focusing on these areas, we can ensure the long-term protection of marine wildlife and address the conservation funding gap. You've completed a comprehensive journey in marine wildlife conservation, covering diverse fields like biology, oceanography, and climate science. Now, CDG Training guides you through professional certification pathways and career development strategies to make a lasting impact. The need for skilled marine conservation professionals is at an all-time high. With initiatives like the 30x30 Target and BBNJ Agreement, opportunities abound across sectors, from corporate sustainability to blue carbon markets. Marine conservation expertise opens doors to various roles in government, international organizations, NGOs, and academia. Each pathway offers unique opportunities to contribute to ocean conservation. Advanced marine conservation professionals must demonstrate skills in ecological science, governance, technical methods, stakeholder engagement, and conservation finance to effectively tackle ocean challenges. Professional certifications, like those from the Society for Conservation Biology and PADI, provide recognition and open doors to advanced career opportunities in marine conservation. Building a strong professional profile involves gaining field experience, engaging in scientific publication, and leveraging professional networks. Emerging technologies and science communication are also key. The future of marine conservation is shaped by new governance frameworks, observation technologies, and spatial planning. Professionals ready to engage with these frontiers will lead the way in conservation impact. The skills and knowledge gained are immediately applicable in various sectors. From government to private sector roles, your expertise can drive significant conservation efforts today. Marine conservation is a moral endeavor, emphasizing scientific integrity, equity, transparency, and continuous learning. These ethics ensure that conservation efforts are both effective and just. The marine conservation community thrives on collaboration. By mentoring, engaging in policy forums, and publishing research, professionals can contribute significantly to global conservation efforts. Addressing climate change is vital for marine conservation. Professionals must integrate climate science into strategies to protect ecosystems and reduce greenhouse gas emissions. CDG Training offers a comprehensive online course for certification in marine wildlife conservation. This program equips you with the skills needed to make an immediate impact in your field. CDG Training's program is entirely online, offering flexibility and accessibility. With self-paced study and online exams, you can earn your certification from anywhere in the world. Certification can transform your career, as seen in the journey from dive instructor to regional conservation leader. CDG Training's program is designed to enable such impactful career advancements. Your certification marks the start of a lifelong learning journey in marine conservation. With CDG Training, you'll continue to build knowledge, skills, and impact, contributing to the ocean's future. Take the next step in your professional journey by enrolling with CDG Training. Join a global community of marine conservation professionals and make a lasting difference for the ocean. Thank you for partnering with CDG Training in your marine conservation journey. Your investment contributes not only to your development but also to the collective effort to protect our oceans for future generations.